Welcome, aspirants. So glad you're joining us today. Look, we are about to break down arguably the single most powerful geographical entity in the Indian subcontinent. This explainer is specifically designed to give you those high-yield insights you absolutely need for your UPSC prelims and mains. We're going to take some pretty complex meteorological data and transform it into clear, actionable knowledge. Ready? Let's get into it.
We have to start by recognizing that the monsoon isn't just, a weather event. As this quote perfectly captures, it's literally the real finance minister of India. We are talking about a massive, complex climate system that directly dictates the survival, the agricultural output, and really the overall economic prosperity of 1.3 billion people. It's huge.
So here's our roadmap for today. We'll start with the anatomy of the monsoon, then dive into global modifiers, examine the economic lifeline, look at the extremes, and finally, unpack the climate change factor.
All right, let's kick things off with Section 1, Anatomy of the Monsoon, getting the baseline of the system down.
Okay, the absolute most crucial concept here is the ITCZ. Think of the Intertropical Convergence Zone as this giant atmospheric switch. During the summer months, as the landmass heats up, this low-pressure trough actually moves northward, right? It follows the sun. And by July, it parks itself right over the Gangetic Plains. This movement is the exact mechanism that physically pulls the moist trade winds from the southern hemisphere across the equator, bending them into those southwest monsoon winds that just bathe India in rain.
Now take a look at the red lines on this map, visually tracking that march. You can actually see the monsoon hitting the Kerala coast right around June 1st and then progressively sweeping across the entire country by mid-July. Keep this vital mental image locked in for your map-based prelims questions. It perfectly captures the spatial and temporal arrival of this entire life-giving system.
Moving right along to Section 2, Global Modifiers. This is where we talk INSO and IOD.
First up, you absolutely must understand the Walker circulation. So this is basically an east-west circulation along the equator, and it's driven by this massive pressure seesaw between the Indian and Pacific Oceans. When the ascending branch of air shifts because of changes in ocean surface temperatures, well, the strength of our monsoon winds takes a direct hit.
And here we brilliantly see that exact impact through the ENSO dipole effect. On the left, we have El Niño. That's abnormal warming in the Central East Pacific, which weakens that pressure difference we just talked about. The result? A weaker Indian monsoon, delayed onset, and serious drought risks. In fact, if you look historically, almost 50% of our monsoon droughts co-occur with El Niño events. Crazy, right? Now flip to the right side. La Niña. Cooler Pacific waters actually strengthen the pressure gradient, bringing us robust winds and above normal rainfall, which, can sometimes lead to floods.
But wait, we also have our very own regional modifier, the Indian Ocean Dipole, or IOD. People often call it the Indian Niño. Take a look at the positive phase here. The western Indian Ocean near Africa gets noticeably warmer than the eastern side over near Indonesia. This positive phase is a total hero for our system. It ramps up convection and brings a lot more precipitation to the western Indian Ocean and the adjacent Indian landmass. Get this, it can even counteract a bad El Niño year.
Okay, I highly recommend you take a mental screenshot of this table right now. Seriously, contrasting these three global modifiers is a guaranteed way to secure marks in your prelims. We've covered INSO and IOD, but also pay attention to the MJO, the Madden-Julian Oscillation. Unlike the others, this is a traveling phenomenon. A quick 30-day cycle moving over the Indian Ocean brings excellent rainfall. But if it stalls out for over 40 days over the Pacific, yeah, it totally suppresses our monsoon.
Let's pivot slightly to Section 3, the economic lifeline. What are the actual stakes here?
64%. I want that number to sink in. This represents the massive portion of the Indian population that is directly dependent on agriculture for their livelihood. And remember, only 55% of India's net zone area is actually irrigated. The entire rest of it? It's completely rain-fed and entirely beholden to whatever the southwest monsoon decides to do.
Just look at this incredible concentration of rainfall. 75% of the nation's total annual rainfall arrives in just 3 crucial summer months. It's a torrential, intense concentration of water. The sheer volume arriving in such a tiny, short window makes rigorous water management, dam storage, and agricultural planning absolutely critical for national survival. There's just no margin for error.
Which leads us to Section 4, Extremes. Let's talk about floods and droughts. $60 billion.
That is the staggering economic cost of just the 285 reported flooding events in India between 1950 and 2017. And the human toll? These events affected over 850 million people. When the monsoon system misbehaves and delivers too much rain too quickly, rivers overflow and the damage to infrastructure and human life is it's colossal.
Notice the severe volatility going on here. On the left, we've got these wild swings in annual rainfall deviations since the year 2000. And on the right, look at how the geographic spread of both droughts and extreme excess rainfall is widening across the meteorological subdivisions. We're literally seeing more areas experiencing severe dry deficits, while at the exact same time, other regions are just drowning in excess.
Finally, we reach Section 5, the climate change factor, the system in crisis.
You're going to want to include these compounding impact points in your exam answers for sure. We are witnessing an erratic withdrawal of the monsoon that is completely ruining post-monsoon crop sowing. Dry spells during the summer monsoon, they've shot up by 27%. But perhaps most terrifyingly, there is a 75% increase in extreme daily rainfall events. We're talking over 150 millimeters in a single day, particularly in central India. The spatial map is literally rewriting itself before our eyes. Less rain where we expect it, like Kerala in the northeast, and more in places like Rajasthan and Karnataka. Pay close attention to how the very timing and delivery of the system are shifting. July was historically our peak rain month, right? Well, now it's declining, while September is getting dangerously wetter. But Step 3 is the most alarming stat of all. 50% of the entire season's rainfall is now often occurring in a tiny window of just 20 to 30 hours. When half a season's rain falls in a day and a half, it doesn't softly water crops. It completely obliterates topsoil and causes massive, deadly urban flooding.
So, I want to leave you with this final thought to ponder, to really debate, and to structure into your mains exams. Understanding the Indian monsoon is no longer just a textbook exercise in physical geography. It's a complex, living study of economic vulnerability and human survival in the face of a rapidly changing climate. Keep these mechanisms and these data points sharp in your mind, and you are going to be incredibly well prepared. Happy studying, everyone!